Hello. In this video we're looking at MEI FP2, the January 2010 paper, question 2c, which is on series. This part question is quite independent of parts A and B, which are covered in the MEI FP2 complex numbers revision video. Here we're asked to write down the Maclaurin series for e to the t as far as the term in t squared. Then it says hence show that. So we need to make sure that we're using the Maclaurin series we've just written down in order to prove the given result. So we start by copying very carefully from the formula book the Maclaurin series for e to the t as far as the term in t squared. Don't worry about the fact that this seems very easy. There is only 1 mark for it, and you are just asked to write it down, so there is no need to show any working. We then take the left-hand side of the expression and substitute into it the series that we've just written down. So that's using the previous result as required. We simplify the denominator and then divide numerator and denominator by t. If we then write that in index notation, we can see that we can use a binomial expansion to write that as 1 minus t over 2, and so on. So we've got our result that t over e to the t minus 1 is approximately equal to 1 minus a half t. Let's have a look at the mark scheme for that question. So there's 1 mark for writing down the Maclaurin series from the formula book. There's a method mark for substituting that series into the expression, an accuracy mark for doing a little bit of tidying up on that. There's then a method mark for using the binomial expansion, and an accuracy mark for completing the whole argument convincingly. There is an alternative way of approaching this, and that is to start with a multiplication rather than a division. So we'll consider e to the t minus 1 multiplied by 1 minus a half t. Again, substituting in the series that we've just written down. Simplifying. Then we multiply out the brackets to get t minus a half t squared plus a half t squared minus t cubed over 4. The t squared terms cancel. The t cubed over 4 is sufficiently small that we can ignore it, and we can say that that's approximately equal to t. From that, we can divide both sides by e to the t minus 1 to get the result. T over e to the t minus 1 is approximately equal to 1 minus a half t. And the mark scheme for this method runs quite similarly to before. B1 for the expression as before, M1 for substituting that in, and an accuracy mark for doing that correctly. A method mark for manipulating that to that point there, and an accuracy mark for a convincing completion of the argument. If you want to find videos of other questions on this unit or on other units, please visit the Further Mathematics Support Programme's website. Goodbye.